cloud. Okay, and we're gonna share screen. We need. Okay. All right. Ladies, Gabe's the only one in class, and he's gonna keep me on my. Make sure I don't get too fast. Let me move this. Yeah. No. Over there, no, yeah, I'm not gonna worry about it. All right, so. Of course, these are our exponents. Don't forget that you have a key on your calculator for exponents. 82. The notes for chapter 4B we're covering tonight. So again, powers, use it on the TI-80 graphing calculator. You got the caret key, and that's your powers key. So what they really want you to do is put these in your calculator and work them out. Keep in mind that 3 to the 4th really just means, if you think on paper or pencil, 3 times 3 times 3. The main things we want to know, that's 81. And you can do it on your calculator. Now this is a -2. We've talked about negative exponents become the denominator, become positive. So when we put that down there, we get a 1/9. Now again, you can do that on your calculator. Put it to exponents. Give you a decimal that you can hit the math key, and it will change it to enter twice. And it would change it to that fraction. Right, so now at 1/2 exponent really means the square root. Now you can put it in your calculator as 81 raised to the 1/2 power. But it's the same thing as asking you for the square root of 81. And the square root of 81 is 9. That's what. And and then the next one, of course, is also asking you. In longhand, it's asking you for the square root of 25 divided by, and because that's a -1 over the square root of 25. That makes the 1/2 positive. Well, the square root of 25 is 5. So I'm gonna have to grab another little thing. You know me. It actually will be 20. Because you're taking 5 and dividing it by one field. So you're really taking 5 and multiplying by 5 over 1. Again, you can put it on your calculator just the way it's written. If I'm going to put the exponents, the fractions in the exponents, I just put them in parentheses. I don't go finding the fraction key. When you change, you do not divide by fractions, you change and multiply by reciprocal. And no, I'm not cursing in the next area. It's just algebra. Y'all can handle it. By the way, this algebra review is on page 218 in your book. If you want to review it, page 218 in your book. So if I'm trying to solve for y, he's got to add a 4. I got to just do the opposite. Subtract 4 from both sides. Find that y equals 3. Excuse me. Something you've been doing since first grade. It just would have looked like this on the handout from the teacher. Fill in the box or the circle or the triangle. Same thing you've been doing in algebra since then. Okay, 2x means 2 times whatever x is standing for. So to solve the multiplication, you do the opposite of dividing. We use the fraction bar to represent division. On the next algebra review, we have s's on both sides, and we've got constant numbers on both sides. So we need to get the s's on one side and the constants on the other side. It doesn't matter. Since I've got more s's on the right-hand side, I'm going to take the negative 4x or minus, make it plus, and add 4s to both sides. Now that leaves 5 on this left-hand side, which I'll call Arkansas side of the Mississippi River. The equal sign's a bridge there. And on the other side in Tennessee, we've got 10s minus 5. Well, since I took my s's to Tennessee, I've got to bring my constant numbers to Arkansas. So that's going to give me 10 equals 10s. Again, this is multiplication. Solve by dividing. We find that s is representing 1. Opposite of squaring something is to take a square root. In fact, if you look on your calculator, your x squared key above it is square root key. So we want to take the square root of x squared. So we're going to take the square root of 36. Now, you introduce the square root symbol. You need to consider possible answers. That a positive times a positive is positive, and a negative times a negative is also positive. So the square root and the square cancel out, leaving your x. The square root of 36 is 6. So there's 2 answers to this problem. And what Pearson will do is if you've got more than one answer that they want, they'll say separate your answers with a comma. And it doesn't matter which order you put them in. You can put the 6, comma, -6, you can put -6, comma, 6.
Like that.
All right. So what we're basically doing tonight is we're going to talk about interest, different type of interest. So the first thing we're being asked about is calculate the amount of money you have in the following account after 5 years, assuming that you earn simple interest. So our first formula we want to talk about is the simple interest formula. That formula looks like this, that the accumulated amount in your account is principal that you put in or borrow, plus the interest. The way we find simple interest is we take the principal times the interest rate, which is a percent that's got to be changed to decimal form. Times the time, and the time has to be based in years. So if they give you 18 months, that's 1.5 years. That's a year and a half. All right, so this is your simple interest formula. Now, ladies, what I did is I gave a green piece of paper. What we're going to do is put our formulas on that sheet so it'll be easier to find in our notes to refer back to when we're working on homework questions. And the first formula I would put on there, and again, this is simple interest. Simple interest, and you only receive interest when you're drawing it out. One time only. Do they calculate it? One time only do they give it to you. And again, the formula that you probably want to keep in mind there is this one right here. The principal plus your interest, which is the PRT. So that's simple interest. Now, the easiest way to change percent to a decimal, it's just divide the number by 100. The percent sign is telling you to divide by 100. So in this particular problem, the amount that's in our account, which is what they are asking us to find, is that we had $1,200 principal, and on that $1,200, they did a 3%. If I divide 3 by 100, it's going to give me this decimal. And it is for 5 years. Now, I can do that all on my calculator in one step because it's going to do the order of operation. So I can take and do 1,200, oops, 100 plus 1,200 times 0.03 times 5. And we're going to get that 1,380 is the amount in the account at the end of 5 years. So you've gone in the bank, you gave them $1,200. This bank is being very good because good luck trying to find a savings account at 3%. They're like point something there. All right. And in 5 years, you go back to the bank and they'll give you 1,380. Now, what you got to remember though, 1,200, that was your own money. Bank only gave you $180 for having your money for 5 years for them to use in loans. The next one, and we're going to put this formula on our sheet again, green sheet, is called the compound interest formula for interest paid once a year. Now, here's what's different for interest in a compound. Simple again, they only pay you the interest one time. Compound, they go in your account, figure out the interest, put it back in your account, and then the next time they figure out your interest, it's not your original principal, it's your new account amount. So compound interest is interest on interest. You get interest on the interest you've already earned. Well, they're thinking you compounded it on top of each other. This is where they got the word. The formula for that, and they've got reason what the letters stand for here, is the amount in the account, the accumulated amount, is your principal times, and in parentheses, you have 1. The 1 is because you got 100% of your principal back. Plus APR, and right underneath it, it tells you that APR is your annual percentage rate as a decimal. And then that is raised to the Y, which is the number of years. Now, I would write that on my green. And the way I would call it was compound interest paid once a year. Compound interest, because we're going to have different compound interest formulas. This one is compound interest paid once a year. So like at the end of the year, they're going to go in there, figure out your interest, give that amount of money into your account. When they go in the next year, you no longer have the original amount. You've got this new account balance that they're going to give you interest on as a principal. And that's how it goes. All right. So on page 84, here's a question. We're going to use the compound interest formula to compute the balance in the following accounts after the stated period of time, assuming interest is compounded annually. Annually is that once a year. For the first couple of times you do this, it probably wouldn't hurt to recopy the formula. And that's why we, I wrote it down, but I didn't write it down. That makes sense. I wrote the title, but I forgot to write down my letters. Again, the one comes from the fact that 100% is one. You get every bit of it back. All right, so if I've got this problem on my paper, I'm gonna again tell myself what formula I'm gonna use. But I have a list here. And then start putting the numbers in. The principal, in this case, was $10,000. In the one is part of the formula. The APR is my interest rate, but I've got to change it to a decimal. So easiest way to do that is just say 2.5 divided by 100. And let your calculator do the decimal for you. And then for the Y years, we've got a 20. Now, you can put this all in your calculator in one step. Just remember to put the parentheses in. If you do not have a scientific calculator that will take it, you need to do it in baby steps. What that does is say, do what's in parentheses first. Raise it to the exponent, then multiply. By order of operations, you would be doing that. But I'm just going to put that in my calculator, the way I've got it written on my paper, and using my caret key to put in my exponent of 20. Notice we're getting a 16,386. If I round it to 2 decimal places for cents, I'm just going to have 16 because of 4 is not enough. So you've taken $10,000 of your money to the bank. In 20 years, you're going to go in the bank and they're going to give you a $16,386.16 check. Now, keep in mind, 10,000 of that was your own money. The banks only paid you $6,386 for having your money with them for 20 years, using in loans and investments.
That they gave like 2% interest.
It'd be great. Good luck. We're talking about the 80s. Mr. Sharnaput and I was talking about that. And back in the 80s, you might have found a bank that does that. Different times. All right. Now again, this is going in your account annually. They're going in, figuring out your interest. They're doing a simple interest, but again, the principal is changing from one year to the next because you earn the interest from the previous year. This is compound interest formula for interest paid in times per year. Okay. The formula looks like this. A, the accumulated amount, is equal to your principal times, and again, we have parentheses. We still have 1. The only difference is our APR has to be divided by the number of compound periods per year. And that's raised to the N times Y. So again, N is the number of compound periods per year. Y is the number of years. APR is your annual percentage rate that's got to be changed to a decimal. Now, here's the information we need to know about N. If you're saying annually, it is 1 every year. If you were to do it semi-annually, that means it's happening twice a year. And that's how most savings accounts are. They usually go in June and then in December, giving you interest. So that's semi-annual. Of course, quarterly, and quarterly is more how taxes are paid if you own a business. Quarterly, N would be 4 times a year, at the end of every 3 months. That's what that would be. Of course, we could have monthly. We're gonna have some problems with monthly. I have no trouble with that being N is 12. We also gonna have weekly occasionally. It'd be very rare, but still, weekly is 52 weeks in a year. And we're also gonna have daily. And daily, N is 365. So that's the numbers that N could be in this formula. So again, to the green sheet. And let's call this compound interest N times a year. I'm writing it on my green sheet of paper, just like this. We write in the formula. That way I have it handy when I'm doing my homework to determine which formula I'm going to need for that question. Enough? Green is easier for you to find in your notebook is what I was doing. All right, we're in the middle of page 84. We're about to use the compound interest formula to compute the balance in the following account after the stated period of time, and notice that it's daily compounded. That right there tells me that we're going to use this formula. A equals the principal times 1 plus, and I'm just putting the letters right now. I'll put the numbers in a moment. N to the N times Y. So this person has invested $2,000. That's my principal. Their APR was 3%. If I take 3 and divide it by 100, I'm going to get a 0.03. And the number of periods, if it's daily, is 365. Now I'm going to raise that those parentheses to the 365 for daily times 5 years. Now we're going to do this 3 different ways. We're going to use our calculator in arithmetic type mode. We're going to go to the Excel spreadsheet and do it. And then I'm going to show you a program that's on the Texas Instrument Graphing Calculator that will let us do it. So do not let me get too fast. All right. Before we start to do this on our calculator, go ahead and take 365 and multiply it by 5, just to make it a little easier to say that you're going to put in 1825 instead. Now you can leave it with a time sign, but it's just easier to put it in as one number. Okay, do it in baby steps. So fill your calculator. Do the division first. So 0.03 divided by 365. Go ahead and hit enter. Now there's a big ugly number on your calculator. Do not write it down. Too soon. Also, do not erase it. Leave it there. Okay. We are still in the parentheses. We've done the division, so now I want you just simply put +1 and hit enter. So that's the number that's in the parentheses. Again, don't worry about writing it down yet. We're not finished. Fair enough? We want to raise it to 1825. So use your caret key and raise it to the exponent of 1,825, which was the 365 times 5. Hit enter. Again, don't worry about writing it down, but don't erase it. We've got one more step. We've done what the division, the addition, the exponent. Now we just need to multiply by 2,000. Now you have it. Write your answer down. Wait till you, and again, we did the division. Then we add. We raise to the exponent. Then we multiply. That was the order of operations using arithmetic step on a calculator. You could put it in all at one step, but I find that if you do too much and don't have enough parentheses, you could mess it up. All right. Now, I will have to come back to this paper. But right now, I'm going to have to go to Excel so you can't see my paper. I should be able to split the screen, but I don't ever can do that. All right, so I'm going to minimize that. And what I'm doing is I'm going to my North Ark login page. You all know you have a 365 Microsoft available to you. So I'm going to it. And if you'll notice over here, it's got me Excel. So all of you have access to Excel. So I'm going to open that up in a new tab to work with. And I think I've got a Microsoft Office too many times, but I'm not going to worry about it right now. All right. We are going to do a new blank workbook. Okay. So if you would like, Gabe, go ahead and get into Excel on your laptop, or probably that'd be the closest. Just go to the, like I said, the Microsoft Office on the login page of North Ark. Ladies, you can get to your computers. Minimize the screen for a moment, or watch the screen and then go and play with Excel. Some people can split the screen, and I should split it, but I'm not going to at the moment. Okay. Before we start, you okay?
Speed.
Hmm. You know when it goes. Want to use my laptop? Okay, let's get in there.
Taking the sweet from
Okay.
the board.
Okay.
Like, I don't know how to get there.
Okay. What I always want you to do is two things before you ever start any assignment. One is pick any block, any cell you want, put your name in it. I don't care if it's on your laptop. I want your name on it. Now, after you put your name in it, any place you want, I want you to go ahead and save it. Save it to your OneDrive that the college provided for you. I'm going to save it, copy online. I'm going to let it go to my documents. I'm going to call it, notes for A. I'm going to put in parentheses PM so that I don't mistake them for my day class, if that's okay with you. And I'm also gonna make sure that my name is given again. So this is notes from 4A that we're doing, so that's what I named it. And I'm gonna say, and now I know it's gonna automatically save, but I'll double check it, saving it every once in a while. Any luck, Gabe? We did on desktop and it takes so long. I'm gonna put you in the Firefox. So, number 2. There. You got it?
Something.
Okay. Okay. This is the easiest way. This is Excel. This is using Excel, and I'm back putting that on my paper, and I'll show you my paper in a moment. I can't show you both. All right. I'm gonna pick another cell. I'm gonna go ahead and type in the information so it make it easier for us to see. This was $2,000. 1, 2, 3, 5 years. Oops. 1, 2, 3. 3% or APR 3%. And daily. I just wrote some information. If it was my homework, I could number it. What problem it was in the book. All right, on another cell. And it can be any place. I just always choose the second column because I'm afraid I'll lose the first column sometimes in printing or something. All right. Up here, you will notice there's an FX function area. I want you to hit it, and this is going to come up. If you go to this, pick a category, pick financial, because we're about to do financial things. All right. What we're trying to find is the future value that's going to be in your account. So if you scroll down this, you will find something called FV for future value. Now, when you hit OK, it's going to ask for certain numbers to put in. And it's going to tell you right here what they are. So I'm going to write this on my paper, and again in a moment, I'll show you my paper. What we did F of X. We chose financial. We're doing FV. And FV is going to ask me to put in the parentheses. First off, it wants the rate. It has a comma. And it's going to ask me for the NPER, which is number of periods for the whole amount of time. Then it's going to ask me for the, and that's the payment. Now, we don't have payments. We're not making payments into. So we will put a 0 there. Then we're going to also give the PV, the present value, how much we put into the account. Then the last thing it asks for is called the type. Type, if you're trying to figure out if you're paying at the beginning of the month or the end of the month. We don't care. It can be omitted. So we're going to close a parenthesis. So here is what we're going to type in based on our problem. We are going to type in that the 0.03 is going to be divided by 365. So when you put in the rate, you've got to divide it by the number of periods in 1 year. Since it was daily, that's why I've got the 365. All right, I'm gonna put a comma. Here is where I'm gonna put that we said it was 365 times 5 years, or you could type in the 1825 that we put on the calculator. Either one. It will compute it for you. Then we're going to put in, like we said, we have 0 payments. We are starting with 2,000. Now, they suggest you can put in negative 2,000 because you're finding what the bank's going to give you, and they didn't give you the 2,000 at the time. But you can just leave it as 2,000. Again, I am through with my formula. So that's the numbers we're putting in. Yeah, we put in the 0.03 divided by 365 days. We put in the 365 days times the 5 years. We put in a 0 payment. We put in the $2,000 principal. When I hit enter, what's going to happen though is I don't get an answer. I get these number symbols. The reason why is I've got to format what I want. So going back to that box, I am right clicking my mouse to pick number format. And it was supposed to get, there it comes, it's just slow. I want 2 decimal places because we're talking money. Now you can pick any of these you want. I'm just going to pick the first one because I'm used to a negative sign. But it doesn't matter because we're not going to worry about signs. I'm going to hit OK. And when I hit OK, notice it gives us the answer we just got from our calculator. Now again, it says negative because that's money going out from the bank's hands to you. Now, what I will be doing is on a test, if you use this to figure out the answer, I'm going to be looking to see what you put in the cell. By putting my cursor there, see, I can see the numbers you put in. And so if it's a mistype, partial credit. But you can do it on your calculator, you can do it here. So again, I'm going to just make sure it's saved. I was in an IT test one time. It was timed. I didn't get things saved. I had to retype everything. So I am very extra cautious anymore. I don't care how many times I have to resave it. I am going to resave it. That's okay. I don't need another name. I just want to make sure it's saved. Okay. So back to our document camera. This is what we typed in. We went to Excel, we went to FX, which is financial, and then we typed in those numbers. All right, so we did it with arithmetic type on a calculator. We did it with Excel. Now we're going to use our calculator with a program that is on the Texas Instrument calculator. All right. On your calculator, you should see a button that says apps, APPS. Mine is in kind of purple letters. If it hasn't been changed, when you hit the apps button, it should give you the name finance.
Mine is simple, a little bit of the finance is hard.
That's usually what's happened. You just had others. So we're going under apps. We're going to use the finance app. So you're just going to hit enter. And when you hit enter, this is what the screen is going to look like. We are doing the very first one. We're doing a TVM solver. We are doing a TVM solve. So if I hit enter, since that's highlighted, it's going, now you're going to see some numbers on mine because I used it in the class earlier today. I'm going to retype all this in. Let me just put zeros right now. I want that, but we'll get there in a moment. Okay, so apps, finance, solve. Okay, so let's write down these letters and what we're plugging in. N is the total number of pay periods. We said that was 1825 on a paper. That was the 365 times 5. Now, the privilege of your calculator when it comes to the I percentage is you don't have to move the decimal. You don't have to type in a percent. You're just going to put the number. In this case, remember, we had a 3% interest. So again, I've typed 1825 on my end. I've gone down and I've typed a 3 for the percentage. The next one is present value. That is going to be our principal of 2,000. I'm going to put minus 2,000 because negative 2,000, excuse me, not minus, but negative, because that's money out of your hands you make. All right. PMT is payment. We don't have a payment, so we're going to put 0 there. Now, the next thing is FV. That's what we're trying to find. So right now on your calculator, I would like you to put a 0 in, but please note, we're going to go back to that in a moment. That's what we're going to solve for. All right, the next two is your payment per year and your interest per year. Both of these are your original ends, and they got to be the same number. So again, here's what my calculator looks like. I've got 1825 for 365 days a year for 5 years. I've got a 3% for interest, 0 present value, no, not 0, it's supposed to be 2,000. Didn't get typed in, did it? And then 0 payments, because I'm not getting payments or not putting in payments. Right now, my future value is 0, and I put 365 for the number of payments per year. And here's what I want you to do. Arrow back up to the FV line. Arrow back up to your 0 in FV. I would then want you to hit your second key, not your second, yeah, no, alpha key, I apologize. I need you to hit your alpha key, the one that's in green on my calculator, then hit enter. And the reason why is if you look in green letters above the enter, it says solve. That's what you're asking it to do. Now, again, you've got to be on the FV line. If you're not on the FV line, it won't work. But on the FV line, I'm going to hit alpha, enter, and there's that answer we found before and in Excel. Again, here you're using the calculator as arithmetic with the formula on paper and pencil. Here is where we did it on Excel spreadsheet. Here's where we use the app finance that's on the Texas Instrument calculator. You do not have to do all 30. You find out which one feels most comfortable to you. Or use 2 of them. Use one of them. The second one's your backup plan to verify your answer. Now, if you use your calculator with apps, tell me the apps, and just like we did, tell me what numbers you put in. That's showing me your work. You wouldn't have to show me this. This would help you though to be able to fill in this information. You don't have to show me that. If you're doing it in Excel, again, I'm gonna find this in Excel. You might want to go ahead and put it on your paper though, making it easier to type it in. You have it ready. That's the 3 ways to calculate the annual, the accumulated amount balance in an N times per year compound interest. Now, the annual percentage yield, APY, also called the effective yield or simply the yield, is the actual percent by which a balance increases in 1 year. It is a little bit different than the APR because of rounding when they go to give you back your interest each time they're going in your account. That last account, every day for that 5 years, somebody was going in your account and figuring out the interest and adding it to your account. We're doing a simple interest. That's the reason why you got quite a bit of money. Yeah. If the APR is annually, the APR and the APY is the same. But if it's more than once a year, your APY is going to be greater than your APR. All right. Page 85. This is just showing you the different compounding periods affect your APY on APR of 8%. So the more times they're going to compound your interest, the better your APY, how much interest rate you're getting is improved. Notice that it's graphing. Notice that you get a lot of interest at the very beginning, then it kind of slacks off. That is called an exponential growth. So those interest formulas we're using are exponential growth formulas. Look like that. They increase quickly and then they kind of flatten off. Now, right here it tells you that the annual percentage yield is a relative increase. And they remind you how we did it, relative increase. What they don't really tell you is the best formula for finding this annual percentage yield. The best formula for it to find the annual percentage yield is to take the interest formula we just talked about. We're going to use 100 or 1,000 for the principal, so we're not going to write it down. We're going to put 1 plus the annual percentage rate divided by n, raised to the n, but we're going to subtract 1. After we raise it to the n, we're going to subtract 1. We're also, after we hit equal, we're going to multiply it by 100 because, again, this is going to be a percent number. The APY is the actual yield your account got because of rounding. APR was what the bank advertised they given as an interest rate. That's the difference in the two. So you might want to put that on your green sheet. Find your annual percentage yield. Plus APR over n raised to the n minus 1. After the equal, you want to multiply by 100 Because you're given 8%. Want to title that? That's annual percentage yield. I don't blame you. So let's continue giving titles. So in this case here, now, please note it says round to the nearest 0.01, so 2 digits behind the decimal. A bank offers an APR of 3.2% compounded monthly. And the APY is a relative increase in the balance of the account over the span of 1 year. The easiest way to compute it. This is how they got the formula, by the way. That's not in the textbook. That one's not in your textbook or ebook. Okay. It's known to find the 1 year balance, compute the relative increase, and express answers in percent. When the principal is not given, any amount can be used. Here we would use 100. So they use that to figure it out. But we're just going to use the formula. So if my APY found by taking in parentheses 1 plus my APR, that's got to be changed to a decimal. You're talking monthly, so the N is 12. I'm going to raise it to the 12. I'm going to subtract 1. After I hit equal, I'm going to multiply by 100 before I give you the answer as a percent. Again, you could do this all in one step on your calculator, but I'd really suggest take baby steps. Take baby steps. So I'm going to clear my calculator. Anytime you need to get out of something like this, it is second in mode. I've got a fresh screen. I'm going to do it baby steps. So first off, I'm going to do my division in the parentheses, order of operations. Again, I'm not writing it down. I'm going to add 1. I'm not writing it down. I'm going to raise that to the 12. Again, I'm not writing down yet. I'm going to subtract 1. Again, not writing down. I'm going to multiply it by 100. Now I'm writing it down. So my calculator is giving me 3.247353032. Remember, the instructions said to give us 2 digits behind the decimal. So I would say that you, even though the bank advertised 3% interest, you actually got 3.25% interest because of the rounding that occurred over each month. Each month, your account is going to be 3.25%. We have one more formula for the day. And it is compounded interest formula for continuously compounding. Now, continuously compounding is more than once a day. But it's not like every hour, it's not like every minute, it varies. But it is more than once a day. It has a special formula, and there's a special key in your calculator you're going to use. Formula is your accumulated amount. Again, they're telling you what those letters stand for right here. Is your principal times natural base E, also known as Euler's E. It is a special irrational number that is a value of 2.71828. It is like pi. It is irrational. It doesn't end and it doesn't repeat. It is on your calculator. You're going to hit second and a button on the left that's labeled LN. Above that, you should see e to the x ready to get its exponent.
Isn't the division key also the same thing?
Yes, the only thing is the division key doesn't have it prepared to take the exponent. That's the reason why I like my second LN, because it's ready for me to punch in the numbers of my exponent. The exponent is your APR. Remember, that's an interest rate, change to decimal, times Y years. I would put it in parentheses. If my calculator doesn't put parentheses on there, I just put parentheses in there and let it multiply for myself. So again, go into my sheet. I'm calling this compound interest. Continuously. Not interest, but continuously. And it was A equals P times the natural base E, you lose E, raised to the APR times the years. For base E, you'll call Euler's E. I like the second LN, but you are correct, Gabe. I could have used the divide sign. Second and divide. We're on page 86. Use the formula for continuously compounding to compute the balance in the following account after 1, 5, and 20 years. Also find the API for APY, excuse me, for each account. Now, we're going to go ahead and set up the formulas for all of these, but then I'm going to show you how you can cut and paste with your calculator. So first off, remember our formula. One with the APR or so for the first one, we have a principal of $2,000. Our base E, our APR, if you think about it, change to decimal by dividing by 100. And we are doing this for, first off, 1 year. And we're going to do the same formula. This time, the only difference, instead of 1 year, let's do it for 5 years. For our third one. Okay. And I'm going to use the cut paste system to do all three of these. I got one, I don't know why it's doing the so long. With as little keystrokes as necessary. All right. Okay, so turn on my calculator and clear off my screen. I'll put it in 2000. I'm going to say times, and I'm going to hit second and LN and put my E there. So I went 2000 times second LN, put my E on. I'm going to put in parentheses 0.031 times 1 and close. Now, when you hit enter, there's your answer. We're rounding to 2 decimal places. So we would say that's $2,062.97, the one not changing the 7. You can sit here and you can retype every bit of that in with now a 5. But you can also hit second and enter, and it retypes the previous line. And by using your arrow keys, you can type right over that one, make it a 5. And get your answer. So again, second and enter retypes the previous line. You can keep hitting second and enter. It will go up 4 lines. Some calculators go more, but I safely feel 4 lines up if you need it. So now, 1 year was $2,062.97. The next, for 5 years, it's $2,335.32. Because the 5 is going to change the 1. Again, I'm not retyping this. I want to hit second and enter. I'm going to go up here and I'm going to change that 5 to 20. I am going to have to retype a closed parenthesis. Find that the answer is 3,717.86. Now, in all those amounts, do not forget that 2,000 was your own money before we started them. Right now, to get our APY for each account, basically. But if you remember, it's for it, all of these. We're going to take the 1 plus our APR, which was 0.031. We're going to divide it by N, which is, oh, we can't do it by N because we don't have compound periods. That'll be why I didn't finish this. I must have got far away at that moment and didn't finish that problem. What did I do today? I don't think I did that problem today, all the way through. So we can't use the APY formula they gave us because N is the number of compound periods and R is continuous. I don't know if you can use an E on that. Right. I don't think I can. Okay, start with the division, 0.031 divided by, this time I'm going to use your E you was talking about, the second and divide. Add 1. I'm going to raise to the E. Right. And it works because times 100. I should have done it with the day class. All right, so I'm getting 3.13. So at a 3.1%, you've got 3.13%. You got a little bit of difference there by them doing continuously because of the rounding. Last problem of the night. The following pairs of investment plans are identical, except for a small difference in interest rates. They want us to compute the balance in the account after 10 and 30 years, and then want us to discuss. So what we've got is we're going to do 10 years first. We've got Jose. And since we're doing it, that it's compounded annually, looking at my sheet tells me that since it's only paid once a year, we want to use this formula. Plus APR to the Y. So for Jose, we've got $1,500. We're doing it 1 plus, remember Jose's doing a 5.6. So his is gonna be 0.56. And in this case, we're doing for 10 years. Now, I'm not doing my calculator yet. I'm gonna go ahead and say that Marta, for 10 years, she's still got 1,500, same amount of money. The only difference is she's doing a 5.7. So that's gonna make this 57. Please. Then we're gonna do the same two people, but we're doing it for 20 years. So Jose, again, is 1,500 times 1 plus 0.056. This time we're doing not 20, I'm sorry, 30 years. For 30 years. 30 years. And then Marta is going to be the 1,500 times 1 plus 0.057. Now, I'm going to be honest. I'm going to put Jose's first one in. I'm going to get an answer. Then I'm going to hit second and enter, and I'm just going to go over and change the 6 to a 7 and hit enter. Hit second and enter, and I'm going to go down here and change the 10 to a 30 for Marta. Second and enter, and I'll go in and change it for his 6 for Jose. Fewer keystrokes. Again, 1,500 parentheses 1 plus 0.056 raised to the 10 Jose's. Two decimal places for money. I'm going to hit second and enter. Oops. Second and enter.
0.21.
Square.
Oh, wait. I know where I'm looking.
Okay.
I was wrong.
All right. So what I'm doing now is I'm just simply going to type over the 6 for 7 to do Marta's. Just hit second and enter, and I retype, just went over there and changed the 6 to 7 for Marta. So Marta looks like she's getting 2,611.21. I'd like to finish this problem. Now, again, I want to skip this one of Jose's because I've got Marta's already. If I hit second and enter, I can just simply change the 10 to 30 and do hers. And then I can hit second and enter, change the 7 to a 6, because I already got the 30 in. To get Jose's. That's the amount in each account, but that's not what the question talks about. It talks about discussing the difference in them. So here's how we're going to choose the difference saturation. Since Marta made the most, let's take Marta's for 10 years. Subtract Jose's, compare it to Jose's. And of course, we're going to multiply by 100 because we're talking about finding a percent. So if you're going to do this in one step on your calculator, put parentheses so that it does the subtraction first. Now, I would do the subtraction, hit the enter, then divide, enter. Or you can put it as a fraction like you're talking about, honestly. Gabe's correct. But I would also do it just in little bitty steps. Do the subtraction. Divide it. And then multiply it by 100. So what's happening is there is a 9.95% difference in their amount of money at 10 years. I'm going to do that same comparison for the 30 years. Again, I could compare tomorrow. They didn't say which way, so I'm just taking it since Jose was first mentioned. We're comparing it using this. So again, 7912.99 minus 769.46 divided by the 7691.46 times 100. Now look at this. If they do a 20%, then there's 2.88% difference in the money that Marta earned over Jose's. Okay, so that's your lesson. You've got some formulas to use. You've got 3 ways that you can do this one. You can do it via calculator, basic arithmetic steps with the formula. You can use Excel spreadsheet with FV, future value, or you can use the app on the calculator. So what I'm going to do is stop sharing. I'm also going to stop the video, ladies, and then we'll clap.